Okay, so let's look at a kinematic problem, and we'll actually deal with this using forces this time. So it says we throw a ball straight up. After we release it, so after it's left our hands, and just before it reaches its maximum height, we want to know what are the forces acting on the ball. So let's draw a quick little picture of what's happening. So I have my little self, and I've thrown a ball straight up, and it's going to go up and then come back down. We want to know what is it when it's right near the top. We want to know what are the forces on it. Well, I'm going to draw a free body diagram. So this will give me my free body diagram. I'm going to ask, what are all the things that are interacting with it? Well, right before it gets to the top, it has an interaction with gravity. The Earth still pulls on this. If it's at the very top, the Earth is still pulling on it. If it's right after it releases our hand, it's still pulling on it. Actually, when it's in our hand, Earth is still pulling on this ball. The mass of the ball wants to be drawn towards the mass of the Earth. We get a weight force. It's no longer in our hand, so our hand provides no force. So the force of the throw, well, it's up here. Our hand's no longer acting on it, so that one's wrong. Gravity is a good one. We have a weight force. Force due to gravity, and it's in the downward direction. So I can eliminate out D because there is no gravity in that one. So all we're left with now is choices B and A. So is inertia part of this or not? Well, if we look at Newton's second law, it says that a net force will provide an acceleration. This is where we add up all of our forces. This is the part that comes from our free body diagram. This right here is our inertia. Actually, it's the mass term is actually our inertia term, but this is where our inertia would come into play. This is where our forces come into play. There are no other forces, no hand on this. The air resistance at that point is actually pretty much zero because it's at zero speed near the top of its arc. So this is the total free body diagram that we get. It just has one force, the downward force of gravity. So if we were to actually plug this in, we would get minus our weight force gives rise to our acceleration. And our weight force is just mg. So this is what gives us our acceleration. We'll see that we have a common factor, our inertia here and our mass term here. They cancel out, so we're left with negative g is equal to a. So this is the reason in our kinematics problems why we get our accelerations in the downward direction to be g. It's because we have one force. It's the force of gravity. The correct answer in this one is we get one force downward. The correct answer is A.